Swayam Prabha. Digital India. Educated India.
Hello everyone. Now the last section of the carding is here. We will discuss some few recent developments related to mechanics of carding, and there are many developments in the carding zone. We are not going to discuss the whole all the developments in the carding, particularly few examples we are going to take here and discuss, and their implications in the quality and productivity of the machine. So, auto labeling, although it is not latest development, auto labeling is also there, already there. By the term auto labeling, it says that automatically labeling the mass per unit length. So, that sliver mass per unit length variation we can control by incorporating the auto labeler in the carding itself. Okay. So, in the draw frame auto labeler is there. So, in carding also now the development is that we can use the auto labeler in carding also. The general aim of manufacturing everywhere is to create durable faultless product, and that is primarily not to correct error, but rather to prevent them. So, what after production we are not going to correct it. When fault is generated, that is we cannot correct it. So, we have to prevent them, especially as far as possible at the start of the process. So, if we can correct the error at the beginning, then we can ensure the quality. In the spinning industry also, the card is effectively the start of the process, since it is a fast process where sliver is being actually produced. So, that is a continuous strand is being produced, and if we can control the uniformity at this stage, then the next stage we can the product will be uniform. But if any defect generated at the card, so thick thin places are generated, so that correction will be very difficult. In draw frame can little bit take care, but that it cannot eliminate 100%. So, it is better to control the mass variation at the draw frame itself. Okay. A relatively high degree of evenness is required in this product. So, because in the next process we are going to add the uniform the non uniformity. So, CV% is added at different drafting stages, that we will discuss in the later stage, how to calculate the addition, how to add the unevenness, but it is better to control at this stage. For various reasons, the card cannot always operate absolutely evenly. For example, owing to uneven material feed. So, that is actually there, uneven material feed is there. So, it cannot because from the back side, from the flock feeder in chute feed, that material sometime although the developments are there where material is actually fed very evenly, that we have already discussed earlier sections, but still we cannot ensure that it is absolutely evenly it is followed, and that is why in the card if we can control the through the auto labeling. So, the sliver production will be uniform. Spinning industry are therefore forced to use auto labeler. So, when we cannot ensure the feed material even feed material. So, we have to go for the auto labeling equipment. It is okay. At various stages, different principles of auto labeling are adopted, okay, depending on upon the quality requirement and operating condition in the industry. So, auto labeling are there, but the sensing the thick thin places are different, that we will discuss in this section. So, there are two types of auto labeling, the principle wise. One is open loop auto labeling and another is closed loop auto labeling. In the carding development, so open loop and closed loop both are in use. So, open loop auto labeling is what is the open loop auto labeling? Now, here the material is actually the setup value is there, and here we are actually sensing here, and accordingly the output speed is changed. Now, a measuring sensor is given placed at A. The measuring sensor can be anything, it can be thickness based, it can be mass based. So, that it is mechanical, it can be mechanical, it can be optical or pneumatically we can measure. So, anything can be measured, that we will discuss separately, but the measuring sensor is provided at the in-feed region and which sense the quantity of material, volume of material here it sense. Suppose here the material is X is the material per unit length is required. Now, it has come Y, if it is more than X. So, that means here the material is becoming thicker. So, if we are getting thick material here, it is sensing, that means it has to be actually made thinner. So, what we should do? We should use the higher draft. So, if it is thin thicker material has come, so up the signal will go at this the output sensor, output device, at where the speed will get adjusted and it will be for thicker material it will be increased. So, the system is that here A is the sensor, B is the store, that sensor will store the data, and then amplifier, C is the amplifier here, and D is the adjusting device. This device will actually change the speed depending on the thickness which is sensed, it will either increase or decrease, but this sensing here actually by optical, mechanical or pneumatic sensing. A regulator is there, here it is a regulator is there, compares the result. So, whatever that this is the store, it actually compares the result, whatever result it is getting, it compares the result with the set reference value. As I have told, X is the set reference value, we are getting Y. If Y is, whether Y is more than X or less than X, that it compares, and then that signal is getting amplified by at C, that is the difference signal, and it is fed to the adjusting devices, okay, which is actuated. It actuates, which then finally converts the impulse into mechanical adjustment. So, that is the mechanical adjustment, either speed has to be increased or decreased. So, control in the open loop system, the control by the this change steps require additional element, namely storage device. So, this storage device is required. Now, since the material has to travel a certain distance between the measuring and the adjusting device, and therefore, it arrives at a certain delay time. So, here material is there, and after delta t time material will reach to this section. The signal must be held back in the storage unit and device and the storage device until at that instant. So, as soon as this is sensing, this material is sensed, it is a thicker material. So, if it immediately change the speed, then what will happen? The normal portion will get thinner and the actual thick portion will not be actually drafted properly. So, that is why we need some storage, signal storage device. This signal store, it will store, and depending on the speed and distance, it will calculate the delay time. So, once the delay time is calculated, then after that time it will send signal, so that the device will adjust the speed. This additional requirement represents the second disadvantage of the open loop system, that is additional lack of self monitoring. So, one problem here is that you need to set the time, storage device is required. Another thing is that important thing is that lack of self monitoring. Now, what we have done, we have actually actuated the speed here, we have changed the speed, but after that whether actually it is the mass per unit length is adjusted or not, that is not monitored. Once it is done, so depending on if there is any change, any variation in delay time, so or calculation or any signal difference is there, then we will get the defective material. So, that is a lack of monitoring is there. So, there is another disadvantage is that since very exact value of adjustment are required for all time. So, we need exact time, distance, speed calculation is required, otherwise it may give some negative impact, it adversely can affect. Now, based on that the problem closed loop system is developed. So, what is a closed loop system? In closed loop system, the signal is at the output section. Okay. So, at the output section the signal is there, where we do not need any storage device. Unlike open loop system, sensor is placed here at the output and then it is amplified and adjusting device. So, at the output we get the signal and the amplifier and then adjusting device, here it adjusts the. So, date time distance is there. The measuring sensor is usually arranged in the delivery region after the adjusting point. So, here adjusting point is there, which adjusts the speed and accordingly adjusts the linear density in case of say sliver, let us take example, but whether it is done properly, that will be sensed once again. Okay. So, the same measuring, regulating and adjusting devices are used, but no storage is needed. We do not need a storage because it immediately it is actually taking action. So, moreover the actual value does not have to be established. So, we do not need to establish the actual value. If too much material passes through the sensor, the regulating transmission device receives a negative signal, reduce the speed. That means, here suppose it is a thick material is there, the material is becoming thicker. Okay. That means, it will give the regulating device negative signal, it will send the negative signal. So, just to reduce the speed. So, reduce the speed means at the feed, that means draft is increased until the actual set value is coinciding. So, as soon as it gets the thick material, the speed gets reduced at the back. So, immediately, so we do not need storage device here. So, time immediately it will get adjusted. Okay. So, but in case of open loop the storage device time adjustment was required. Here immediately it will, the speed will get reduced or increased. Neither a positive nor a negative signal is produced when there is a where there is a coincidence, the instantaneous speed is maintained. Okay. The principle is substantially simpler than open loop system. This is very simple because you do not need storage device. The measured portion has already passed the adjusting point. Okay. So, this is when the adjustment signal is arriving. So, comparison cannot be actually, that compensation cannot be achieved in this measured portion. So, here when you have measured, the problem here is that once the material is drafted, it is measured in this point we are measuring, that is coming out. Here the, let me explain this. So, suppose at this point its thick portion is there. So, it is assuming that at the back thick portion is coming. So, it will, when you are reducing the speed of the back roller, it is able to adjust at this zone, but whatever we have sensed, that portion is going undetected, actually controlled. So, compensation cannot be achieved in this measured portion, that we cannot compensate, that is some of the long and medium term error. So, this will become a long term error at the yarn. Okay. Are there, all of these short term errors remain in the product. So, this type of the some whatever this wherever we are measuring, that portion is not getting corrected. So, it is therefore clear that closed loop control is unsuited to compensate irregularity over the short length. That particular portion it will not be able to correct. So, we have to take decision which one we need to do. So, that is why in industry both open loop and closed loop systems are available, and depending on our requirement we can choose either open loop or closed loop system. Now, in the new card system, integrated control system is there, that open loop and closed loop control system, integrated systems are available. Here you can see here in this system, this is the carding machine. Here the signals are that is a output signal, that is a feed speed in the chute. So, here we have one signal is there, okay, feed speed, and which is going to the control unit. The feed speed is controlled here, okay, and control light barrier is, this is also going to the central control unit. Output signal of feed roller. So, output signal of feed speed of the chute we are controlling. At the feed roller, which is actually feeding the to the card, that is controlled here, and input signal of in feed count, here in feed count is also controlled here. That signal is that whatever whichever what is the count of the material coming inside the in the card, that is the bat thickness or lap thickness, that we are controlling. Input signal of the delivery speed, also it is controlled. Input signal of sliver count. So, everything is controlled here, it is going to the central signal processing unit, and from there it is integrated, it is a controlled at a time. So, irregularities can actually be compensated at different zone. In the material supply system. So, at the material supply system we can control the irregularity. At the infeed we can control the system. At delivery point we can control. At delivery we can control. So, in this integrated system which is developed, and where we can control at each and every system from the infeed to delivery. So, there we can ensure that the output material is very uniform. So, we can now classify based on the regulating length. So, at which point you are regulating. So, based on that we can classify. If we regulate at the back, that will ultimately create the long term irregularity of the sliver. If we regulate at the medium, at the midpoint, that will create the medium term regularity, that is ultimately length of the sliver will be that length, and at the delivery it is a short term irregularity. Now, we can see based on the length we can classify the short term leveling regulating product from the 10 to 12 centimeter, okay, rarely used in carding. So, that 10 to 12 centimeter it is a very small length. So, we normally do not use in the carding. Medium term leveling, which is about 3 meter length, and long term leveling about 20 meter, to maintain the count, maintaining the count of the sliver. Now, short term leveling is that you can see here in some of the cards they use in the short term irregularity. So, here when at the feed delivery, here we have different system of controlling. The A is the deflection roller, ensure vertical feed to measuring funnel. So, here this is the measuring funnel, measures the sliver weight, incoming sliver. This we will discuss. Here the measuring funnel 2, which works on the pneumatic principle. The principle I will discuss subsequently. Now, this is a drafting system and output measuring funnel. 2 and 4 are the measuring funnel, which is a sensor, pneumatic based sensor, which based on that the speeds are controlled. Okay. The delivery roller feed the sliver to the sliver coiling system, and then it goes to the can. In the open loop control, a measuring point is provided in upstream. Here a measuring point is there, okay, upstream, from which the drafted arrangement sends the volume of the incoming sliver. So, volume of the incoming sliver is measured and transmits the corresponding pulse signal to the control unit. So, here it measures the volume and then accordingly the sliver count can be adjusted in the. So, in the at the delivery point, after the doffer, after the sliver is formed, it sends at that point 2 and point 4, and accordingly if there is any variation, again one draft arrangement is there, 3/3 draft arrangement, small draft it adjusted. So, it is a actually in additional draft is actually attached with the carding machine. The control signal generated by this unit is passed to a regulating devices, and that can be of various design, okay, which adapts the speed of the delivery of the drafting roller. So, it controls the drafting roller speed. Now, for different cards, it is basically for C60 RSB is equipped with the digital short term leveling system, and the mass of the C60 card sliver is scanned with the well proven tongue and groove type leveling system. So, tongue and groove type rollers are there, which actually sense the thickness. In pneumatic loading of the rollers guarantee the constant scanning. Based on the measured value, the leveling processor actually calculates the normal value and it gets actually actuated. Okay. It is transferred at that exact instant when the measured piece of the card sliver arrived at that leveling point within the main drafting zone. So, that because it be depending on the open loop and closed loop system. So, it will actually get actuated at that point. Now, medium and long term, earlier what we have discussed, it is a short term at the exit point. The medium and long term is that for medium the sensor is placed above the cylinder. So, in Worcester controller system is there, okay, where in Zellweger Worcester the equipment, in this equipment a medium term auto leveler was provided as an additional system to the long term auto leveler. So, here it is a medium term auto leveler is there. So, in medium term auto leveling what happens? It works on optical measuring device. So, optical system. So, an optical measuring device is which detects the relative variation in cross section of fiber. So, here optical measuring device is there, there is a slot provided above the cylinder or some portion between the flat zone and the doffer, this is the doffer zone. So, that on and where it measures the thickness of the operating layer. Okay. So, cross section the operating layer on the main cylinder over the whole width. So, this is actually the sensor runs over the whole width and which sense the relative variation in the cross section number of fiber, okay, or thickness. So, the measuring device is built into the protective cover above that. So, this works on optical measuring devices there and which measures the thickness of the operating layer. If the thickness is more or less, accordingly the speed is changed. Measures the reflection, it measures the reflection of the infrared light from the fiber. So, if the reflection is high, that means its thickness will be more, if it is low it will be vice versa. So, accordingly it measures the thickness or presence of fiber and it changes the speed. Now, after comparison with the set value, a difference signal is generated and passed to the electronic regulating system using the either open loop or closed loop system. So, here it generates the electronic signal and then it goes to the control unit which controls the speed of the feed roller, feed system. So, accordingly it controls the sliver linear density. This operates via a regulating device to adjust the in-feed speed of the card. So that the depth of the fiber layer remain constant in the on the cylinder. So, that is important here by controlling the feed. And for long term auto leveling, measuring is performed by a sensor at the delivery roller. Long term auto leveling is an integral part of the modern card. Now, what are the different sensors for auto leveling? So, mechanical sensors are there, pneumatic sensors are there and electronic sensors are also there. So, mechanical sensors are basically typically tongue and groove type. So, this is the tongue and groove type sensor, where if there is a variation in thickness, this tongue will roller will move up and down and that will get signal. This is most common system for deriving the measured value, because here we can use the tongue and groove, because the slive we are talking about the dealing with the sliver which is thick one. So, any variation will get reflected by the this groove and tongue system. Usually two material forwarding rollers are there. These are the two material forwarding rollers are there. One of this roller must be movable. Typically at the top one, upper one is movable, it moves up and down relative to the other one, that is bottom one. The relative movement corresponding to the volume of the material passing through gives the instantaneous value required to the to be regulated. So, it depending on the upward or downward movement. So, immediately it will control the speed of the drafting roller. So, that we can control this movement. Roller can be smooth or grooved, that is B and C, that is a smooth roller, and also can be grooved. The later arrangement prevents the lateral escape of the fiber, and thus gives more precise. So, here if the fibers are there, so fibers will be entrapped in that groove. So, it will give a precise measurement, but here in this system fiber can come out from the this point and it may give some wrong result. However, it must be so designed and must operate in such a manner that fiber is not crushed. So, this roller should be in such fashion. So, fiber it does not crush the fiber, the roller mass of the roller it should be that it should not be too high. Now, another system is that here at this modern feeding system, this is the fiber is fed. If there is any, and here it is a spring loaded, and if any variation is there here, so this will move up and down. So, that will give signal to the feed roller. So, the in the feed of the card, the feed measuring device records the fluctuation of cross section of the bat. So, if the bat whatever feeding, if there is any fluctuation, this will move up and down. That movement is controlling and it gives signal to the feed system. The speed of the feed roller of the card is changed electronically, so that these fluctuations of the cross section are leveled out. And last one is pneumatic one. This is the pneumatic system. Now, here you will see that the sliver pneumatic system is attached with the trumpet, and during trumpet where the fibers are moving through that sliver is being formed, here if there is any variation. So, whatever air is entrapped in the sliver, through this channel, through this channel air comes out, because it is compressed and excess air is coming out here, and depending on the variation of the fiber, the number of fibers or mass variation, the amount of air passing through will be different, and there is a pressure transducer which sense the pressure, whatever pressure is coming, set pressure is there. If there is any change, it will send signal. So, pneumatic system is there. In a normal card, a funnel, the trumpet is provided before the calendar roller. This is calendar roller, to collect the wave. In Zellweger equipment, that is the sensors, pneumatic type sensor, this funnel is developed as a measuring device based on the simple physical principle. What is the physical principle? When it is compressed, and that will release the air. When the fiber material enters to the funnel, it carries along with it certain amount of air between the fibers. Owing to the continuous coverage of the funnel, the air is squeezed out as the material pass through. So, air is squeezed out, and depending on the air, as I have mentioned, air amount, the sensor sends signal. This generates air pressure excess atmospheric pressure, that is air pressure it is generated, and which is a function of the sliver cross section. So, higher sliver cross section means higher air pressure, and that accordingly we can control the speed of the delivery to control the fiber linear density variation. If all fibers characteristics remain same, this pressure is proportional to the volume. So, if the fiber cream, fiber length remains same, so depending on the volume, if the volume of the feed is more, that means pressure will be more. So, a lateral bore is created corresponding leads which transmits pressure to the chamber of pneumatic electronic pressure transducer, and using this electrical induction to convert the pressure into electrical signal. So, here the transducer is there, and this signal goes to the delivery roller. So, here the signal is there. The advantage of this pneumatic measurement lies in the simplicity. It is a simple one, and which does not require additional system, additional moving part. Here only thing is we are actually modifying the trumpet. Once you are modifying the trumpet, that means you can actually process the material. Main disadvantage is that measurement is affected by the fiber count, hence the count variation can lead to error. So, if the fiber linear density is more, that means fiber the entrapment of the air will be different, that will give some error. Now, other miscellaneous development we will just discuss here quickly. So, Ritter are C60, the main differences are what is that, it is increases the working width. So, working width is increased to get the productivity. Okay. Reduce cylinder diameter for that better transfer of the fiber, and cylinder speed is increased because you are reducing the cylinder diameter. So, we can increase the cylinder speed up to 900 RPM, and pre-opening is introduced before the carding. So, at after the chute feed, so flock feed, again one pre-opening is introduced here. The integrated fine opener at the chute with the feed roller is which adjusts the with the adjustable speed is provided, which gives the gentle but effective fiber opening. So, here during the transportation through the duct, fiber may the get again it the tuft formation, it may get compressed again during the rolling and the friction. So, again we have some gentle opening, so that the fiber, whatever fiber is coming here for the liquor in, which is little bit effective opening is there. Okay. Fine opener is given. This shifts the opening from the cleaning machine to the card, gives definite advantage. So, the cleaning will be better, because here what happened, we are actually opening the fiber, and due to suction here also the trash is removed here. So, lower nape increase due to the fiber transportation, because we are opening pre-opening the fiber, gentle open due to the low production rate here, and these well opened tuft are fundamental for effective carding. So, we are and for nape and truss reduction. So, we are here it is a well opened tuft is produced, it is actually provided. So, active compensation active compression is there. So, an integrated fan, okay, provides the active compression of fiber material, which is the base for an even and uniform structure. So, here the fibers are actually the fan is there. So, which will ensure the uniform structure, mat structure. Okay. This again is essential for a permanent high sliver quality, low count variation, low CV of yarn and high production efficiency. So, this pre-opening is very important. And another development is that the 3 liquoring system. So, instead of one liquoring what happened, when the compressed tuft is coming, large tuft is coming, in one liquoring it may not be able to open properly. So, 3 liquoring system is also provided to maximum the trash removal and gentle fiber treatment at the carding zone. So, it gives a better opening. Carding segments and mote knives are there. So, it is a carding segments and mote knives at all rollers efficiently extract the fibers. Here in all rollers carding segments are there. So, it extracts the trash particle. As a result, production up to 200 kg per hour is there. So, you can increase the productivity. As a tendency towards the high rotor speed continually, this use a small rotor diameter, okay, becomes necessary. So, where because in the rotor spinning we need fiber sliver with a very less stress. So, low stress, because otherwise it will rotor will be clogged. For small rotor diameter where we go for very high speed. So, their stress is actually not desirable. So, for this type of yarn we use 3 Likarin module in the carding. So, trace particles it is minimized, and which is successful for small rotors in the rotor spinning, because small rotor is used for high production, high speed production. And another system development is IGS system, it is a integrated grinding system. So, there are one is how is it working? IGS classic, a grinding stone automatically moves across the cylinder clothing. So, a grinding stone will be there which automatically moves along the cylinder clothing after certain predetermined time. So, you do not have to stop the machine, it is integrated and fitted typically at the bottom of the cylinder, and when during the process, okay, when the feed is stopped, so then we can actually grind the cylinder. An optional module sharpen the card clothing, card flat clothing usually automatically. So, IGS top, IGS classic is for cylinder, IGS top is for flat. Flat automatically it gets grinded. The control calculates the grinding cycles over the pre-selected site. So, we can control. So, after certain time automatically the grinding will start. So, that is a predetermined time is being set. So, where you can see this is the normal grinding, which is manual grinding, where the wear points becomes blunt, and in the lifetime few 3 to 4 times we can do in the life, because it actually the wearing of the wear point is very high, you can see the depth. But in the case of the automated IGS system, it automatically in a lifetime it does many times with a small depth. Okay. So, rounded card edge. So, this is the rounded carding edge which is reducing the effectiveness of the carding in the normal system, and 3 to 4 times in the lifetime. So, in the lifetime 3 to 4 times on the span, to whole lifespan. But here in this IGS system, it is sharp carding edge, always you will see that carding edge is sharpened, because it is a sharp carding edge, and in case of normal you can see this is blunt. So, carding action is reduced, and in a lifetime 300 to 400 times we can grind. So, continuously the quality is maintained. So, constant sliver quality over the lifetime of the wear, better carding, that is stress and nape reduction is there. So, continuously the nape and trace removal will be better, no downtime. So, best thing is that you do not have to stop the machine, the grinding is done automatically during the in the cylinder and flat, automatically during running time. Otherwise, in manual production, what happened, manual system, you have to open up the card and you have to take out the cylinder, then the grinding takes place, where the downtime is more. But in modern carding system, the IGS system is there, where automatically it gets grinded, strongly reduce the maintenance load. So, maintenance load is not, you do not have to do maintenance, automatically it is, you just set the time. Prolonged lifetime for cylinder wears, therefore very economical, ideally suited for latest wear technology, which are difficult to grind manually. So, latest wear, it is a very hard metal. So, the manual grinding is difficult there. So, you can see here the NAPS count, this is the normal manual system, NAP count increases very high, then you are grinding, and here again it is increasing. But in IGS system always it remains, after certain time you increase the grinding efficiency, then it will drop. So, the NAP count is always under control. And the last part is the modular system for different section for easy maintenance and flexibility, like modular concept for Likarin, where and modular concept for flat, modular concept for Doffer. So, keeping the cylinder in its position, so you can actually change the, take out the Likarin, take out the flat, take out the Doffer for maintenance, proper maintenance. The this modules reduces the maintenance load, the pressure on employee and machine downtime. So, you can do quickly, the easy exchange of modules make the card adaptable to the whatever the end product is there. So, immediately you can change this system, and in addition to the normal flat, stationary flats are there, which is fixed on and which is in play in the zone when in the working alongside the main cylinder to open, separate and align the fibers. Additionally, offer advantage like simple design, reduce wear and tear. So, you can see in Trussler, in addition to this, that some stationary card system is there. These are the different stationary system card segment. In the area of the pre-carding zone, 3 carding elements are there, okay, with the 2 clothing strips and 2 cleaning elements. So, this is also on development in carding. Now, we have discussed the few latest developments. So, we will stop here, and we have finished the card section, and next we will start the draw frame. Till then, thank you.